Hyperbolic functions. These are very useful in the scientific calculations. So before learning the hyperbolic functions, we need to learn what are the exponential series, what are the logarithmic series. So now I'm going to write the exponential function e power x. I'm going to write its series and it is defined as follows. You need to remember this formula very carefully. The value of e power x. This is always equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so on x to the power of n by n factorial. So you can see it very clearly. As we increase the denominators in any fraction, the value of the fraction will be always increases. Okay now. So for the greater value of n, the finally the value of the denominator will becomes a big number. Now you can understand this fact very clearly. If I write in the place of x1, what will happen? So here 1 will come 1, 1, 1. In the last term, especially in the last term, 1 to the power of n, that is 1 only. So 1 by n factorial. Suppose if I take the number of terms as 10 lakhs. So you'll get a number, the last term 1 by 10 lakhs. It is a small value which is less than 1. So that value we can neglect. So that means here also you can see very well, as we increase the powers of x, so already I took here in the place of x1, 1 square, 1 cube, that all the numerator value will be the 1 only. Here also 1 by 1 factor 1 only. So this 1 plus 1 will gives us only the number 2. But this side, all the values are in a decreasing order. Finally, the last term value approaches to 0. That means here we will get this all the terms from the third term of this expansion. All the terms are the proper fractions and they are arranged in the decreasing order. If you add this all the proper fractions, definitely you will get a small number which is less than 0 and greater than 0. So you know very well the value of the proper fraction always lies in between 0 and 1. So the sum of the fractions from the third term of this expansion, that is always greater than 0 and the less than 1 will come. So maybe it is a 0 point something it will come, and the 1 plus 1 it will give us 2. 2 plus 0 point something it will come. So then you will get the value of e power x like that. So not only the e power x. So this is a series of e power x. Now what I am doing in this with this series here, look at carefully. Now I want to write in the place of x there 1. So if I write in this exponential series in the place of x1 there, then this series will becomes 1 plus 1 by 1 factorial plus 1 square by 2 factorial. 1 square it is nothing but 1 only. So 1 by 2 factorial, then 1 by 3 factorial. Like that you will get the final term, it is 1 by n factorial. Here n number of terms are there. Not only n number of terms. So I think here if you consider them very carefully, we will have n plus 1 number of terms are there. Why? Because in the second term 1 factorial, third term 2 factorial, 3 factorial. From the second term only the factorial it is started. 1 factorial, 2 factorial, 3 factorial, like that n factorial. So till here n terms are there, including n plus 1 number of terms are there in the exponential series. Okay now. So now 1 by 1 it is, we know very well this is 1. 1 by 2 factorial means 1 by 2 into 1, that is 1 by 2 will come. 1 by 2 is nothing but 0.5. 1 by 3 factorial means 1 by 3 into 2. 1 by 6. 1 by 6 means you get a small number which is less than 1, greater than 0 only. If I divide 1 by 6, you will get something 0.16, like that it will come. So that can be also negligible. If you add from the second term that all the values are, if you add from the third term only, that all the values are just more than 0.5 will come. And this is 1 plus 1, total is 2. 2 plus 0.5 and something will come. Okay, so you will get the value of e power 1. Approximately it's, so you can conclude here very well. The value of e This is always lies in between 1 and 2 only. Is it clear to all of you? No, E does not lies between 1 and 2. Why? Because E is equal to here 1 plus 1 factorial. Here, till here only 1 factorial it is there. 1 plus 1 factorial. Total will be the 2 na? This is 2. Okay, we'll do, we can write directly the value of E, it is always lies in between 2 and 3. Why? Because till here the sum is 2 and it is 0.5. So total it is 2.5 will come. So more than 2.5. That more than 2.5 number, it is always lies in between 2 and 3. Okay now. So this E we call it as exponential number. Exponential number. Its value we have, that is 2.713. So instead of writing the number 2.713, you can use the letter E. So actually the value of E, it is never be equal to 2.713. Every exponential number, it is always an irrational number. When we take that irrational number in the decimal form, it never ends with any digit after the decimal point. So that means this number will goes on like this only. So after 3 we may have many digits. We can't guess it. We can no need to write that number. So in most of the irrational numbers which are in the decimal form, we call them as non-terminating, non-repeating decimal, or else you can say them as non-terminating, non-recurring decimals. Okay now, every non-terminating, non-recurring decimal, it is always an irrational number. So this is one of the example of irrational number. Like pi, it is there. We know very well pi, it is most probably all the people will say value of pi, it is 22/7. Actually the value of pi, it is never be equal to 22/7. 22/7, it is in fractional form. That pi should not be in the fractional form. Pi is always an irrational number. So its value, it is in the non-terminating, non-repeating decimal as 3.1425. So on many digits will come. But 22/7, it is a fractional number that is nearly equal to the pi value. So that's where instead of writing that all the pi value in the non-terminating, non-recurring decimal, most probably we will try to take the value of pi equal to 20/7. Okay, pi is approximately equal to 20/7 only. Right? Pi is always an irrational number. 22/7, it is a rational number. And one more thing you need to remember always one thing. What is that? An irrational number never be equal to the rational number. Both the numbers are different, but they may be closer to each other. So here by seeing the exponential series, e square equal 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, so on, plus x power n by n factorial. This is called exponential series. And if we substitute x equal to 1 there, you will get like this. And now I want to write the value of e square. E square means I am substituting in the place of x2 there. Then this expression changes to 1 plus 1 by 1 factorial. Again you write it as 1 only. Plus this is in the place of x, what do you write? Yeah, in the place of x, what do you write here? The 2. So 2 will come here. This side 2 square by 2 factorial. We can write 2 square by 2 factorial. And then the next one, it is 2 cube by 3 factorial. Like that the many terms will come. Okay, like that we can able to write the value of e square. If I want to find the value of eq in the same exponential series only, we need to write in the place of x equal to 3. So eq will come 1 plus 3 by 1 factorial plus 3 square by 2 factorial plus 3 cube by 3 factorial, so on, 3 to the power of n by n factorial, like this it will come. So most probably you people need to remember the value of e power 1. E power 1, it is nothing but 1 plus 1 by 1 factorial plus 2 by 1 by 2 factorial plus 1 by 3 factorial plus so on 1 by n factorial. That is the formula of e power 1. And in some of the problems we may have a chance to use, we may have a chance to write the expansion for e power minus 1 also. Now what I am doing, wherever the x I am writing there minus 1 in the equation 1 only. So then it will becomes 1 plus minus 1 by 1 factorial The third term will becomes minus 1 square by 1 factorial. Minus 1 square it is, plus 1 will come. Isn't it? The third one, next term, in the fourth term, minus 1 cube, 1 whole cube by 3 factorial. That is minus 1 will come after the simplification. Right? So I am writing minus 1 here. So that is 1 by 3 factorial. And for the next term, minus 1 to the power of 4, that is will come only 1 only, plus 1 to the power of 1 by 4 factorial. Next, minus 1 by 5 factorial. The terms will come, so on. Okay now? So now, just you need to remember here. You need to remember here. What I am doing here. Like that, we can able to write the series of e to the power of minus x also. Okay, you can guess it very clearly. That is, since e power x equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, so on, x power n by n factorial. Then e power minus x will be 1 plus, here in the place of x we should write minus 1. So it will become minus 1 by 1 factorial. And the next term will becomes minus 1 whole square by 2 factorial. The next term will becomes minus 3 minus 1 whole to the power of 3 by 3 factorial, so on will come, that all the terms. Then the last term will becomes minus 1 to the power of n by n factorial, isn't it? So now on simplifying them, you will get x e to the power of minus x is equal to 1. This will becomes minus 1, and the next one will becomes plus 1 by 2 factorial. Next one becomes minus 1 whole cube, it is nothing but minus 1. Whenever we have the odd number which is a power to the negative number, we have to always take here the positive sign only, negative sign only. So that is minus 1 by 3 factorial plus so on. So on. Here, this is a minus 1 cube by 3 factorial over. So on. The last term, we can't say whether we get here the minus 1 or the plus 1 here. That depends upon the value of n. If I take n equal 6, which is an even number, this will becomes plus number. If I take minus, means this will becomes minus. That's where we need to write unless knowing that whether the number n it is an even or odd, write the last term as it is only here. So once you consider what I am saying here, the first one and this last one, look here carefully. So I am assuming this one as the second equation, this is the first equation. So what I am doing here, I want to take this both the equations at a time. Okay, so then we can understand. And one more thing here, this is e to the power of minus 1 we should write here. Okay, we forgot to, we need to mention here e to the power of minus 1, and it's correct only. In the next step we can write. Okay now, this value will come 1 minus 1 plus 1 by 2 factorial minus 1 by 3 factorial, so on. And e to the power of minus x is it is correct one only. Now here, look here very carefully. We have substituted in the place of x equal minus x na. So here also we need to take care the x terms here. X will come this side x square, and this is x cube, and the last one it is x to the power of n also we should take like this. Right. So now what I am doing here. So just look here carefully. So we have written this e power minus 1 and e power minus x reversely here. Okay, actually before doing that e power minus 1, we need to write the expansion for e power minus x. So these both are the very important to you people. Now what I am doing, I am taking these both the equations and once I am adding this both of them, and then after we can separate the second equation terms from the first equation. So if I add this both the series, what will happen here? E power x plus e power minus x will come now here. So I am writing that one, e power x plus e power minus x. So I think its value will becomes, look here, 1 it is of 2 times, here this is 1 it is there in e power x in the first term, here also 1 it is there. So we can write 1 plus 1 2 now. So they take 2 as common here. Look here, this is very important you people to write. I am writing this all the steps in the directly, and this second term and here the second term. I think this plus x by 1 factorial, this is minus x by 1 factorial, this both will get cancelled. And third term x square by 2 factorial it is there, plus x square by 2 factorial, that means it will becomes 2 times of x square by 2 factorial. So after taking 2 common, we write only x square by 2 factorial. So like that, the power of x cube by 3 factorial minus x cube by 3 factorial, if you add them they will get cancelled. So then you will get only the even terms here, like this x power 2, x power 4 by 4 factorial plus x power 6 by 6 factorial plus so on it will come. Okay, is it clear to you? You can consider this all the terms carefully. Here we are getting only the even terms only, the power of x here, x square by 2 factorial it is of 2 times, x power 4 by 4 factorial it is 2 times, like that it is coming. And just you consider the first term 1 and here the 1 it is there. So 1 plus 1, there you get 2. So after taking 2 common, here we need to write one more 1. Isn't it clear? Is it clear to all of you? So then you will get one thing here, the formula for e power x plus e power minus x divided by 2. This is same as here 1 plus x square by 2 factorial plus x power 4 by 4 factorial plus x power 6 by 6 factorial, so on it will come. So similarly, if I subtract the first second equation term, the first equation, what will happen? Like this only I am going to write it directly, e power x minus e power minus x by 2. I am writing its value here. So directly I am writing. So from this terms I am subtracting, from this expression I am subtracting these all the terms. So here 1 minus 1 will become 0. And the second term x by 1 factorial, here minus of minus x, minus of minus x means plus x will come, x plus x 2x will come. I think here this expression will start with the letter x plus x cube by 3 factorial plus x power 5 by 5 factorial, so on it will come. So you can remember this both the series very easily. So what is the expansion for e power x plus e power minus x by 2, that is 1 plus x square by 2 factorial plus x to the power of 4 by 4 factorial plus x power 6 by 6 factorial, so on. Similarly, e power x minus e power x by 2, it is only x plus x cube by 3 factorial plus x power 5 by 5 factorial plus so on will come. So just you people remember here, this the first one it is then e power x plus e power minus x by 2, that thing we call it as cos hx. We write as like this, look here, cos hx. This is a hyperbolic function, cos hx, but it is not equal to the cos x. Cos x and cos hx both are the different. So this is we can write its series here like 1 plus x square by 4 factorial plus x cube by x power 4 by, sorry, this is x square by 2 factorial plus x power 4 by 4 factorial plus x power 6 by 6 factorial. Okay, now this is a series of cos hx. And sin hx series also we can write here, that is we will start with sin hx, this one x plus, sorry, x you can write it x plus x cube by 3 factorial plus x power 5 by 5 factorial plus x power 7 by 7 factorial, so on. So you need to remember this both of them. Okay, now this both of them are equal to here. This is same as to write e to the power of x plus e power minus x by 2. You need to remember this cos hx formula series. So wherever the cos hx, you can write there e power x plus e power minus x by 2. And the series of cos hx is that 1 plus x square by 2 factorial plus x power 4 by 4 factorial and so on. You need to remember. And wherever the sin hx, you can write e power x minus e power minus x by 2, this thing. Now what I am doing, I want to divide these both of them. So I want to write sin hx by cos hx. Sin hx by cos x equal to this left hand side by left hand side. So here 2 will get cancelled, finally it becomes numerator. So then you will get the formula as e power x minus e power minus x by 2. 2 will get cancelled. So whole divided by the last term will come e power x plus e power minus x. This sin hx by cos hx, this is nothing but tan hx. So like that we can write tan hx in terms of the exponential series as e power x minus e power minus x by e power x plus e power minus x. You need to remember this all the aspects. So now one more thing here, this is very important you people to write cot hx. Cot hx, it is you can write reversely cos hx by sin hx. So in the exponential form we can write e power x plus, take the reciprocal of it, e power minus x by e power x minus e power minus x. And cosecant hx, cosecant hx, it is nothing but 1 by sin hx, remember. So since the sin hx is equal to e power x minus e power minus x by 2, then cosecant hx will be the 2 by e power x minus e power minus x will come. Now you tell me the what is the reciprocal of the secant hx? It is a reciprocal of cos hx. So means we need to write its reciprocal, that is nothing but, so you can write 1 by cos hx, that is nothing but here 2 by e power x plus e power minus x. So you need to have this all the hyperbolic laws which are in terms of e power x, and this is you people, this is most important to remember the formula, the expansion of e power x, it is that 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, so on will come. So and we'll have the logarithmic series as well. So there we'll discuss about them in the next class. And please be practice please all of you practice this all the series very carefully, try to understand them, how to write this series in the order. So better to learn what is meant by sin hx, what is meant by cos hx, tan hx, cosecant hx, secant hx and cot hx, and try to write that hyperbolic ratios in the exponential series form also. We will meet in the next class. But